Let's evaluate our trig functions for multiples of pi over 2, otherwise known as 90 degrees. So let's evaluate cosine of 0. Using our definition on the unit circle, we are going to rotate our arm nowhere. It's just going to stand right here. The point on the circle corresponding to our terminal side is 1, 0. So the cosine of 0 is the x coordinate there, right? 1. Sine of 0 is going to be the y coordinate, which is 0. How about pi over 2? Well, pi over 2 is a quarter of a revolution. So our terminal side will be pointing straight up. The point on our unit circle is 0, 1. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1. About the cosine of pi. Pi is half a revolution. So our terminal side will be pointing to the left on the x-axis. The point of the circle there is negative 1, 0. So the cosine of pi is negative 1. How about the sine of 2 pi? Two pi is a complete revolution. So our terminal side ends up on the x-axis pointing to the right. On the unit circle, that corresponds to the point 1, 0. So the sine of 2 pi is the y-coordinate there, which is 0. Let's do one more. How about cosine of negative 5 pi over 2? Right, using the circle, we can evaluate our trig functions for any rotation. A rotation of negative 5 pi over 2 is going to head in the clockwise direction. So let's see here, pi over 2, or negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, negative 5 pi over 2. So there's our rotation. The point corresponding to that rotation on the unit circle is 0, negative 1. So cosine of negative 5 pi over 2 is equal to 0. So let's look at the functions that are not sine and cosine. Say we evaluate tangent of 0. When we use the circle, it's easiest, I think, to think of tangent, secant, cosecant, and cotangent in terms of the sine and the cosine. Tangent of 0 is the sine of 0 over cosine 0. Right? That's an identity that we have. Here's my 0 rotation. Sine here is the y-coordinate, that's 0. Cosine is 1. So the tangent of 0 is equal to 0. Let's try another one. How about tangent of pi over 2? Well, this is going to be the sine of pi over 2 over the cosine of pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. So this is undefined. All of these trig functions that have division in their identity by cosine or, as we'll see in a moment, sine, have points on the circle where they are undefined. Tangent is certainly going to be undefined when the cosine is 0. So tangent will be 0, or undefined rather, whenever our rotation lands us at 0, 1 or 0, negative 1. Okay, these points give us an undefined tangent. Let's look at one more. Let's look at cosecant. Let's evaluate cosecant of pi. Cosecant of pi is 1 over the sine of pi. So here's a rotation of pi. It lands us at the point negative 1, 0. The y-coordinate there is 0, right? Sine of pi is 0 here. So the cosecant is undefined. At a rotation of pi radians, right? Since we are dividing by sine for our cosecant, any rotation that lands at 1, 0 or negative 1, 0 is going to be undefined.